Hello friends, this video on Communication Systems Part 12 is brought to you by examfear.com. No more fear from exam. Okay, so now we are clear with the idea of what is the need of modulation. We all know why is modulation needed. Now let us try to understand the carrier wave in detail, because whenever we talk of modulation, we will be talking about a high frequency wave. That means that our message signal is a low frequency wave. But how are we going to translate it into a high frequency wave? With the help of another high frequency wave, which is known as a carrier wave. For example, if we take the previous example of that letter, so the letter is our low frequency message signal and the train is a high frequency wave. So a high frequency signal to which the information of the original message signal is attached. So what do? In the process of modulation, we pick a high frequency wave, right? Now we change something in that high frequency wave such that we can attach the information of the message signal into that high frequency wave. Right? So that is what we do. We do not make any changes to the message signal. So here, whenever we'll talk about modulation, there will be two things which are involved. So what are the two things involved? One is the message signal. Now the message signal means the signal which is sent by the sender and the transmitter. So that is a low frequency signal. And the second one is the carrier wave. So carrier wave is a high frequency wave. Now we will not make any changes to the message signal during the process of modulation. Why? Because message signal contains the information and we do not want any change to the information. The information has to be retained. It is something like if I am talking to my mom over the phone, if I say, "Hello mom, how are you?" I do not want this information to get changed. Now, if I am telling, "Hello mom, how are you?" and if my mom hears, "Hello mom, what are you doing?" So the information is getting changed. So there is no process, no use of such a communication system because I want to communicate the information which I have. So there should be no change in the message signal. So the message signal remains unchanged. So where will the modification happen? The process is modulation. That means modifying. What will get modified? This high frequency carrier wave is the one which will get modified. Now, how will it get modified? That is what we are going to study in this topic of modulation. That how the carrier wave is modified so that it carries the message signal intact without causing any change to the information. So that is our agenda here. So this carrier wave can be a sinusoidal wave, that is a sine wave, or it can be in the form of pulses. So this is a sine wave. We are all familiar with. These are pulses. So what are pulses? Pulses are nothing but they are similar to square waves. So they basically represent the digital signals, right? So carrier wave can be either of them. It can be a sine wave, it can be a pulse. So let us now talk about the types of modulation in case of sinusoidal waves. Because as I said, carrier waves can be of two types. It can either be a sinusoidal wave or it can be a pulse. So in case of sinusoidal carrier waves, let us see what are the different types of modulation possible. So what are the different types of modulation which we will talk about? We are going to talk about amplitude modulation, frequency modulation, and phase modulation. So these are the three types of modulation which we will be discussing for a sine wave. Now before that, there are certain features of sinusoidal waves which we should be aware of because we will be using them quite often. And I have also covered them in the previous lessons when we talked about the lesson on oscillations, the lesson on waves, the lesson on electromagnetic waves. So in all those lessons, I have already discussed about each of these characteristics of a sinusoidal wave in detail. Right? So when I say different types of modulation, how do you think that modulation can happen in many different ways? Well, when I say modulation, what is it? It is nothing but a modification which happens in the carrier wave as per the message signal. Right? Now, this modification in the carrier wave can happen in many different ways. The modification can happen in the amplitude of the carrier wave, then we call it as amplitude modulation. If the modulation happens in the frequency, we call it frequency modulation. If it happens in phase, we call it phase modulation. So I'm sure that many of you already remember what is amplitude, what is frequency, and what is phase, but still, for those who do not remember them, let us have a quick review of these parameters of a wave, because in case any of you do not remember them, then it will really be difficult for you for the next half of the lesson, because I'll often be using these terms. So let us have a quick recap of the parameters of a wave. So what are the different parameters which describe or which characterize a wave? Amplitude, phase, wave number, wavelength, time period, angular frequency. So these are some of the parameters or some of the things which actually describe a wave. They can describe a wave. Now, I'll not talk about all of them in detail, but most of them are being used when I talk about modulation. So let us have a quick review of each of them. What is amplitude of a wave? It is the maximum displacement of the elements of the medium from their equilibrium position as the wave passes through them. So the key point here is maximum displacement from equilibrium position. So that defines the amplitude. So it is generally denoted by a capital A. So if you think of a wave, a sinusoidal wave in this form, so this is the maximum displacement, right? Because here the displacement is this much, here the displacement is this much, here the displacement is this much. So gradually the displacement is increasing. So the maximum displacement is this distance. So this is defined as the amplitude of this wave. And equilibrium position is this position. This red line denotes the equilibrium position or the mean position. Next is phase of a wave. What is phase? It describes the state of motion as the wave sweeps through an element at a particular position. So it talks about the state of motion of each point on a wave. So let us look at the wave so that we get a better understanding. Now, if you look at this wave, if you look at the behavior of this point and the behavior of this point, so both of them have the same behavior. Both of them are trying to move upward, right? So these 2 points are in phase with each other. That means both the points are in the same state of motion. But if you compare this point with this point, are they in the same state of motion? No. This point is trying to move up, whereas this point is trying to move down. So they are not in the same state of motion. So we say they are out of phase. Similarly, if you compare this point with this point, do you think they are in the same state? No. Even though both of them are trying to move up, but the way this point is trying to move and the way this point is trying to move and the way this point is far away from the topmost position is different from the way this point is far away from the destination, right? So these 2 points are also not in phase. So this point, this point, this point, they are all in phase. Similarly, this point, this point, this point, they are all in phase. Again, this point, this point, this point, they are all in phase, right? So you remembered the concept of phase. So it talks about the state of motion of a particular point, right? Okay. Next is wavelength of a wave. What is wavelength? It is the minimum distance between 2 consecutive points in the same phase of wave motion. It is generally denoted by lambda. So if you take this wave, just consider any 2 points which are in the same phase. So this point and this point. These are the 2 points which are in same phase. So the distance between these 2 points is lambda. Similarly, if you consider this point and this point, they are in same phase. So the distance between these 2 points is lambda. So this distance and this distance, they are equal, right? So the distance between any 2 points which are in the same phase is known as wavelength of a wave. So here I have shown the wavelengths both in case of a transverse wave as well as a longitudinal wave. I hope you remember these terms. Anyways, I'm not going to discuss them in detail right now. In transverse waves, the movements are perpendicular to the direction of wave propagation, but in longitudinal wave, they are in the same direction. Anyways, even if you don't remember, you can refer the videos on waves. Okay, let us look at the next parameter, that is the angular frequency. Before that, let us try to understand what is period of a wave. What do we mean by period or time period? It is the time taken to move through one complete oscillation. That means, let's suppose if the oscillation starts, so how much time it takes to complete one oscillation, that is known as time period. So, in simple terms, if you have a wave like this, right? So how much time it takes for this wave to complete one oscillation, that is one cycle. So this is one cycle, right? From here the same repetition starts. So this is the second cycle. This is the third cycle. So the time it takes to complete one cycle or one oscillation is known as time period, or it is also known as period of a wave. It is denoted by capital T. Now we will talk about frequency of a wave. What is frequency? The number of oscillations per unit time. That means how many waves occur in a time period. Now let us understand it in this way. Let us suppose I have a wave like this, and I have another wave like this, right? And let us suppose I have yet another wave like this. So I have three different waves. So what is the time period of this wave? The time taken to complete one oscillation, and this is one oscillation, T. Now for the same time period T, if you see, for the first wave in time period T, how many oscillations happened? 1. Now for the same amount of time, how many oscillations happened for the second wave? 1, 2 and 3. So for the second wave, 3. What about the third wave for the same time period? 1, 2, 3, 4, 5, 6, 7. Right? So the number of oscillations per unit time. So if you keep the time constant in all of them, then in which wave more number of oscillations happen? The third one, right? So we say the frequency of the third wave is 7. So the frequency is maximum for the third wave and it is least or minimum for the first wave, right? So now you understand what is frequency of a wave. So if I am talking about a high frequency wave, it would look somewhat like this. If I am talking about a low frequency wave, it will look somewhat like this. Clear? Okay. So it is generally denoted by nu. Let us now talk about angular frequency. So now once the term frequency is clear, it will be easier to understand angular frequency. It is very much related to frequency. It is just that when I talk of frequency, I am talking in linear terms. But when I am taking into consideration the angle, when I am taking into consideration the circular aspect of it, we involve angle into it and then we call it as angular frequency. So, like how we have linear velocity and angular velocity, how we have linear acceleration and angular acceleration. Similarly, we have linear frequency and angular frequency. So how do we define angular frequency? So angular frequency is defined as 2 pi nu. So this is angular frequency and this is linear frequency. So with this linear frequency, you added 2 pi, right? That is, the angle is incorporated into it. Now frequency is calculated as inverse of time period. That is the relationship between frequency and time period of a wave. So we can say that angular frequency is equal to 2 pi by t. So that is all about the angular frequency of a wave. So now if I say that I have any sinusoidal wave in general, so how do I denote or how do I describe a sinusoidal wave? Because just before some time I told that if we are aware of all these parameters, if we know the frequency of a wave, the period of a wave, amplitude of a wave, phase of a wave, if we know all these things, we can describe the wave. So now let us suppose that we know that we have a wave whose amplitude is A. Let us suppose that I am talking about this wave itself. So if I know that its amplitude is A, its time period is T, its angular frequency is omega. So how do you think will we denote or describe this wave? So the signal strength or this wave can be described as A sine omega t plus phi, where y is again a function of time because the signal strength is also varying with time. Now, what is this yt? It is either voltage or current, because whenever we are talking about signals, we are talking either in terms of voltage or current. So this is equal to amplitude sine of omega t, where omega is the angular frequency, plus phi, where phi denotes the phase constant. Right? So this is how we denote a sinusoidal wave. Now that we had a recap of these parameters of the wave, let us try to see the different modulation types of sinusoidal waves. Now, depending upon the parameter of the carrier wave, the parameters which we discussed, now one of these parameters can be modified in the carrier wave. Now, depending upon which parameter is getting modified, we classify that modulation into a specific type of modulation. Now, how the modification will happen, that is determined by the message signal. So, there are three types of modulation: amplitude modulation, frequency modulation, and phase modulation. So, amplitude modulation, when the amplitude of the carrier wave gets modified. Frequency modulation, when the frequency of the carrier wave gets modified. Phase modulation, when the phase of the carrier wave gets modified. Please understand this, that during modulation, no change happens to the message signal. The modification or the modulation happens to the carrier wave. Now, any one of the parameter of the carrier wave will get modified, either the amplitude or the frequency or the phase. Right? So we will now talk about amplitude modulation, phase modulation, and frequency modulation in detail one by one, just to see that how exactly this modulation takes place. Thank you. Please visit www.examfear.com to watch more videos, attempt free online test, get free study material, find tutors and mentors. Thank you once again.